Hi my students in grade 8. This is an additional mathematics sheet for semester 1. This sheet is prepared with exercises that you can solve, and this will be the solution of the exercises. Hope you are all doing well, and see you soon. Question number 1, we should write the following in the form of a single power, which means here we have two powers. We should get an answer of 1 power. We are multiplying two powers having the same base. The rule says we keep the base as it is and we add both exponents. So 5 plus 7 is 12, so we add the exponents 5 and 7. Also, we have 6 times 6 to the power 4. 6 has no exponent, which is 6 to the power 1. So the answer is we keep the base 6 and we add 1 plus 4 is 5. Also here we keep the base, which is 10, and we add both exponents. 2 plus 6 is 8. 10 to the power 1. So we keep the base as it is 10 and we add the exponents. 3 plus 1, so it gives me 4. Here we have a power of power, so we multiply both exponents. We keep the base 5, and when we multiply 2 times 8, it gives me 16. Now also here we have a power of power, so it is 8 to the exponent. 3 times 2 is 6. 4 times 0 is 0, so here we get 11 to the exponent or to the power 0. Here if we multiply both exponents, we keep the base 4 and we get to the exponent negative 10. Here we have division of same bases, so we keep the base 10 and we subtract the upper exponent minus the lower exponent. So the base is 10. 7 minus 3 is 4. Also here we keep the base 10 and we say 10 minus 4. So we subtract the lower exponent. Now we get 10 to the power 14, because negative and negative is positive, so 10 plus 4 is 14. Also here we get 10 to the power negative 4 negative 5, because when this gets up it becomes negative, so this is 10 to the power negative 9. Here we should calculate these exponents. If you can see here, we have a negative base. When we have a negative base, we look at the exponent. The exponent is odd. 3 is odd when the exponent is odd. So my answer will be negative, and 2 cubed is 2 times 2 times 2, which is 8. So it's negative 8. Here the negative that we have near the 1 or in front of the 1 has nothing to do with the exponent. So we have negative, and 1 to the power 207 is 1. Here it's a negative base. We look at the exponent. It's even. It is an even exponent. Because we have an even exponent, so my answer would be positive, and 1 to the power 410 is 1. 2 times 3 is 6 to the exponent 2. Here 5 minus 7, so my answer will be negative 2, all of it squared. Also here we have a negative base. To the power even, my answer would be positive, and 2 squared is 4. 9 to the power 0, any number to the power 0 gives me 1, and 0 to the power 9, any 0 to any exponent gives me 0, so 1 plus 0, my answer will be 1. Here we have parentheses, so we start inside the parentheses. Inside the parentheses we have exponents, so we get the answer of 1 cubed is 1 minus the answer of 3 squared is 9, all of it squared. Now the answer of the parentheses 1 minus 9 is negative 8. My answer is inside parentheses because we still have an exponent. Also we have a negative base to the power even, so my answer will be positive. You can write the plus or without the plus. And 8 squared is 8 times 8, which is 64. Also, a negative base to the power even, my answer would be positive, and 2 squared is 2 times 2, which is 4. Here it's not a negative base, we have a negative outside that doesn't have anything to do with the exponent, and 2 squared is 2 times 2, which is 4. The negative is outside the parentheses, then it has nothing to do with the exponent, and the answer of 2 squared is 4. Here we have a minus outside, so we keep the minus. A negative base to the power even gives me a positive, and 2 squared, its answer is 4. So here we have negative 4. Now the answer of the parenthesis, 5 times 3 is 15, and we keep the exponent, which is cube. Inside the parentheses also we have an exponent, so we should get the answer of the exponent. So it is 5 minus 2 squared is 4, and all of it squared. Now the answer of the parentheses, 5 minus 4 is 1, and 1 squared, so my answer is 1. Here we have power of power, so we multiply 4 to the power 2 minus 3. 2 times minus 3 is minus 6, so it's 4 to the exponent negative 6. Now here also we have a power of power, 0 times 11 is 0, so we get 5 to the exponent 0, any number to the exponent 0 gives me 1. Also again, because this is very important, a negative base to the power even gives me a positive. 2 to the power 4 is 2 times 2 times 2 times 2, which is 16. Here the negative has nothing to do with the exponent, so we keep it negative, and also 2 to the power 4 is 16. Here the exponent is odd, so negative to the power odd is negative, and 2 cubed is 2 times 2 times 2, which is 8. Here the minus also has nothing to do with the exponent, and 2 cubed, its answer is 8. Any number to the power 0 gives me 1, as the rule says. Here we have a minus outside. Here we have a power of power, so we get minus 1, all of it to the power 10. We have a negative base to the power even, so it gives me 1, and 1 to the power 10 is 1. So here we have the minus outside, so it's negative 1. 10 to the power negative 3. This is a negative power of 10. So it will give me a decimal number, 0 point, having 3 digits to the right of the point, which is 0.001. Here we have a fraction, and in the denominator we have a negative exponent, so we get it up, and we will be changing the negative exponent to a positive exponent, so it will be 10 to the power 5. 1 to any exponent always gives me 1. To write any number in scientific notation, we should always know that any number written in scientific notation, we should have a multiplied by a power of 10, and the exponent might be positive or negative, in condition that a should be a number between 1 and 10. It could be 1, but it cannot be 10. It should be always less than 10. This is any number written in scientific notation. So 657.4. We ask, is 657 a number between 1 and 10? No. Let's make it. To make it, we should move the point from here to between 6 and 5. So we will get the number between 1 and 10, which is 6.574. Also, we should multiply by a power of 10. This should be a positive power of 10 because we have no zeros to the left of the point. We have moved the point 2 digits, so it is 10 to the power 2. 2.7, this number is already a number between 1 and 10, so we keep it 2.7, and because we didn't change this number, any number not changed is multiplied by 10 to the power 0. Here we have the zeros to the left of the point. Let us split between the zeros and the number. Is 86 a number between 1 and 10? No. How can I make it between 1 and 10? I write it 8.6. Now I should multiply by a power of 10. Here the exponent should be negative because the zeros are to the left. We count 1, 2, 3, and we moved it 1, so they become negative 4. Now here we split between the number and the zeros. Is 318 between 1 and 10? No. Let's make it between 1 and 10, so it's 3.18. Let's multiply by a power of 10. Here it's a positive power of 10. We count the zeros first. 1, 2, 3, 4, 5, 6, and we moved it 2 digits. Then the power of 10 would be 10 to the power 8. Is 9 between 1 and 10? Of course, 9 is between 1 and 10. So always we multiply if the number is not changed by 10 to the power 0. This number we split. Is 8 number between 1 and 10? Yes, so we keep it 8, and now we only count the zeros. Why? Because we didn't move the point. 1, 2, 3, 4, 5, so it's 10 to the power 5. Also here, is 1397 a number between 1 and 10? No. Let's make it a number between 1 and 10. So we move the point in the number to get a number between 1 and 10 multiplied by a power of 10, which is, let's move the point from here to here. We moved it 3 digits, so 10 to the power 3. So we split. It's not a number between 1 and 10. Let's make it. It's 9.02 times 10 to the power. Let's count. 1, 2, 3, 4, and we moved it a digit, so it is 10 to the power negative 5 because the zeros are to the left. Let's choose one. For example, this, let us split. 7 is a number between 1 and 10 because the zeros are to the left of the point, so it will be a negative exponent. 1, 2, 3, 4, 5, 6, 7, 8, so it is to the power negative 8. Also, 9.5 is a number between 1 and 10, so we keep it 9.5. Any number kept in scientific notation as it is, we multiply it by 10 to the power 0. Here we have 0.728. Also, let us split. Let's make the number 725 a number between 1 and 10, so it's done between 1 and 10. So we moved the point from here to here. We moved it 1 digit, so we multiply by 10 to the power negative 1. This is how we write any number in scientific notation. To simplify such numbers, we directly look at the base. Here the base is 4. It's not a prime number. 16 is not a prime number. 2 is a prime number, so we keep it as it is. But here we have a power of power, so we should make them one exponent. How can I make 4 a prime number? Using prime factorization, we write the prime factorization is of 4. 4 is divided by 2. If it's divided by 2, it gives me 2, and 2 we can divide it by 2, it gives me 1. So what is 4 in scientific prime factors? As prime factors, 4 is written 2 squared. Why did I write it in between parentheses? Because the 4 has an exponent outside, which is the negative 4, times, to find the prime factors also of 16, we should make the prime factorization. 16 divided by 2 is 8, 8 divided by 2 is 4, and 4 divided by 2 is 2, 2 divided by 2 is 1. So the prime factors of 16 are 2 to the power 4 because we have no exponent outside, so we write it without parentheses. Here we have a power of power, negative 4 by negative 2, negative by negative gives me positive, 4 by 2 gives me 8. Also here we have exponent, power of power, we multiply, so it's 2 to the power negative 8 times 2 to the power 4 times 2 to the power 2 to the power 8. Now 2 to the power negative 8 cancels 2 to the power 8, so we get 2 to the power 4 is my answer. This is the simplified form. Here we have a fraction. Also first I look at the exponents. All my exponents are positive. That's okay. Whenever we have positive exponents, now we look at the bases. The base is 36, not prime. 25 is not prime. 6 is not prime. 5 is prime, so we keep it. Let's keep the base 10 aside now till the end. So also we make the prime factorization of 36. 36 written as prime factors. When we make it, it is 2 to the power 4 times, sorry, it is 2 squared, I'm sorry, it is 2 squared times 3 squared. These are the prime factors of 36, all of it to the power 5 times. If we write 25 as prime factors, it is 5 times 5, which is 5 squared, and outside we have to the power 4 times. Let's keep now the base 10 after we simplify. 6 as prime factors, it is 2 times 3, all of it to the power 9 times 5 to the power 11 times 10 to the power 6. Now let's get rid of the parentheses. This here we have a power of power, and here we have a power of power, so it is 2 to the power 2 times 5 is 10 times, also in the second one we have a power of power, so it is 3. 2 times 5 is 10 times, also here we have a power of power, 2 times 4 is 8, so it is 5 to the power 8 times 10 to the exponent 9. Also here we get the exponent inside, so it is 2 to the power 9 times 3 to the power 9 times 5 to the power 11 times 10 to the power 6. Now let's simplify. Here we can simplify only those that have the same bases together. Here we have base 2, base 2. We ask where the exponent is more, up or down. It's up. So we will have 2, and we subtract the exponents. 10 minus 9 is 1, so it is 2. Also 3 to the power 10 and 3 to the power 9. It's the exponent is in the numerator more, and 10 minus 9 is 1. 5 to the power 8 and 5 to the power 11, it's more in the denominator, and 11 minus 8 is 3. 10 to the power 9 and 10 to the power 6, it's more in the numerator, so we have 10, and 9 minus 3 is 6 is 3. Now we will deal with the base 10. Now let's change 10 to prime factors. What are the prime factors of 10? We should always know that without any change, the prime factors of 10 are always 2 times 5, and we write cube over 5 cube. Now let's get the power 3 of the parentheses inside, so we write 2 times 3 times, let's get the exponent inside for everyone, 2 cube times 5 cube over 5 cube. Here we have the 5 cube, cancels the 5 cube. Here we have base 2, so we have same base, we keep the base 2, and we add the exponents. 1 plus 3 is 4, 2 to the power 4 times 3 over 1, so my answer will be 2 to the power 4 times 3. This is my simplified answer. In question number 5, we will calculate square roots. In addition and subtraction of square roots, we should know a very important rule which says in addition and subtraction we can only add or subtract the radicals that have the same radicands. Here the radicand is 5 and here the radicand is 5, so we go and we look at the coefficient here and the coefficient here. -3, -8, because both are negative, so it will give me negative, and we add 3 plus 8 is 11, and we keep the radical as it is, so it's negative 11 radical 5. Also here we have radical 11, same radicands. 7 minus 6 is 1. When the coefficient is 1, we don't write it, so we write directly it's radical 11. 6 radical 10 minus 2 radical 10 minus 4 radical 10, also same radicands. So 6 minus 2 is 4, minus 4 is 0, so here the answer will be 0 radical 10. Whenever the coefficient is 0, so all my answer will be 0. Here we have 2 and 5 as radicands, so we do the radical 2 together, the radical 2, the radical 2. 3 minus 8 is negative 5 plus 1, this is negative 4 radical 2. Now after we finish with the radical 2, we go to the radical 5, so we do the radical 5 with the radical 5. 7 minus 1 is plus 6 radical 5. Also here all of them have a radical 3, so minus 9 plus 3 is minus 6, plus 10 is 4, minus 8 is negative 4, and we keep the radical 3 as it is. Now we are multiplying radicals. We don't, here in multiplication, we don't care if they have the same radicands or no. Radical 11 times radical 11 gives me radical 11, all of it squared. Now the squared cancels the radical, so my answer will be 11. Radical 5 times radical 3, so here we have different radicals, so we keep the radical, and 5 times 3 we multiply, it's 15. Now 2 radical 7 times 3 radical 5, we multiply the coefficients, 2 times 3 is 6, radical 7 times radical 5 is radical 35. 3 radical 2 into 4 minus 2 radical 2. Here we multiply the first by the first and the first by the second. 3 times 4, we multiply the numbers, it is 12, and we keep the radical 2 because we have no radical here. So minus 3 times 2 is 6, and radical 2 times radical 2 is radical 2, all of it squared. Now the square cancels the radical, and we get 2. 6 times 2 is 12, so here we have 12 radical 2, 12 radical 2 minus 6 times 2 is 12. So the answer is 12 radical 2 minus 12. Also here we should multiply the first by the first, the first by the second by the first, and the second by the second. 1 times 5 radical 3 is 5 radical 3. 1 times plus radical 7 is plus radical 7. Minus 3 times 5 is minus 15, and radical 7 times radical 3 is radical 21. Negative times positive is negative. 3 times 1 is 3, and radical 7 times radical 7 is radical 7 squared. Here the squared cancels the radical, so here we get negative 21. We cannot add or subtract these because the 3 is different from 7, is different from 21, different radicals. Now we will simplify radicals. Also when simplifying, we ask, do we have a square inside? Yes, so the square will cancel the radical, and my answer will be 5. Also here the square cancels the radical, my answer will be 7. Also here the square cancels the radical, my answer will be 10. Here we have a negative square, it becomes positive, and the square cancels the radical, so I get 7. Here the minus is outside, so it's minus, the square cancels the radical, so my answer is 4. Here, when we have a negative radicand, here this is impossible or written in a wrong form, or this does not exist because a negative radical never exists. Now radical 25, I ask, can we write 25 as a perfect square? Yes, it is 5 squared. Now the squared cancels the radical and I get 5. Can we write 36 as a perfect squared? Yes, it is 6 squared. The squared cancels the radical and I get 6. Can we write, negative is outside, so it's kept outside. Can we write 100 as a perfect squared? Yes, it is 10 squared. The squared cancels the radical and I get a negative 10. Can we write 50 as a perfect squared? No. So here we should write the prime factorization of 50. 50 is divided by 2. It gives me 25. 25 is divided by 5. It gives me 5. And 5 is divided by 5. It gives me 1. So 50 is written as prime factors. It is 2 times 5 squared. Because inside we have multiplication, so this can be split into 2 radicals. So we write radical 2 times radical 5 squared. In the radical 2 we have nothing. Here the squared cancels the radical, so we get 5. So radical 2 we keep it as it is, and the answer of radical 5 squared is 5. Any radical multiplied by a number is written 5 radical 2. Also 80 cannot be written as a perfect square, so we will make its prime factorization. 80, if we divide 80 by 2 we get 40. If we divide 40 by 2 we will get 20. 20 divided by 2 I get 10. 10 divided by 2 we get 5. 5 divided by 5 we get 1. So 3 is a coefficient, we keep it radical. 80 is written as 2 to the power 4 times 5. Now let us split the radicals. So 3 times radical 2 to the power 4 in the first radical times radical 5. Now let's look at 2 to the power 4. Here we have an even exponent. Always an even exponent is written, to simplify it, is written as a power of power. What is 4? It is 2 times 2. So we write it 2 squared, all of it squared, times radical 5 equal 3 times. Here in the second one, the square here outside cancels the radical, and my answer will be 2 squared times radical 5. Now 3 times 2 squared, it is 3 times 4 times radical 5. 3 times 4 is 12 times radical 5. So my answer is 12 radical 5. In this way we simplify radicals.